Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
I was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later from our college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they not only focusing on study, they are also conducting different exam to test our knowledge, and as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course, which was for
Yeah, good evening, guys. Hope I'm audible and the screen sharing is also working. Can you confirm that with a yes in the chat box? Audible? Audible and the screen sharing is working. Good evening. Done. A lot of other people are still joining. Okay, we'll get started. We'll not waste any time. So today will be another visual spectacle for you. Okay, so as I said, linked list is one of the easiest concepts and it's one of my favorites actually. Okay, I love teaching linked list. Yesterday we have gone through some questions in linked list in lead code. We have solved three questions. First one is finding out the middle of the linked list. Second one we have gone through a binary conversion. Third one is a simple deletion of node. We have seen how basic operations generally work and all. Okay, so let's go through lead code again. Today we will be solving by using fluid Marshall cycle detection algorithm. We'll see cycle 1, cycle 2. We will also see, okay, what do I say? We'll also go through reverse. That's another important question. And we have one more small concept called a dummy node. Okay, these are the models. You will be using slow, fast pointer, previous current pointer, the two pointer technique, two variations. Next, fluid cycle, like fluid Marshall cycle detection algorithm is there. Apart from that, you have reverse. Apart from that, you have dummy node. Okay, as per my knowledge, if you know these things, you will be able to go through every linked list question. Okay. Now, linked list we have, let's get started with cycle detection. So we'll go with CYCLE. Right, so linked list cycle we have. Let me click here and let me delete the previous code if I have solved it. Done. Now see here. Go through the question. It's question number 141, linked list cycle. Okay. Given head of the linked list, determine if there is a cycle in it. For example, you see we have a linked list. I hope you can point out. Linked list is not pointing to none. Linked list is again circling back. It is pointing to some other value. Okay, so that's one thing. Again, same here. Again, if you observe here, we don't have any cycle. So if you have a cycle, you have to return true. If you do not have one, you have to return false. Okay, that's it. There is a cycle in the linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote. So you don't have to worry about this position. You see, they're telling position is not passed as a parameter. This is just for you to check for hidden test cases, etc. and all. Okay. If you want to go with your custom test case, you want to have a cycle at some point, just for that input this is, you don't have to write it. Okay. This is not even considered. Do not even consider it. Now, since they do not give each and every memory address also, they are telling you that this is the input and this is where the cycle is going to be from the last node. That's how it is. Done. Now see here, if there is a cycle, what do you have to do? Return true. If there is none, you have to return false. Now, as I said, in some companies, let's say you don't know the answer for this one and you have seen something called true or false. You will be awarded marks based on how many test cases you have passed. Okay, it's not like how many lines of code you have written. For these type of questions which are having true or false, you see, if I simply return, let's say there will not be much, okay, or there will be much. I'll take a guess between true or false. Let's say I want to go with true. Okay, let's say you don't know the answer for this one. In some of the companies, if they are giving you true or false as a question, submit true or false. You will be able to get half of the marks at least. Okay. You see, true, 12 out of 29 test cases passed. If I go with false, and if I submit it again, see here, even if you did not write the entire answer for it, some companies will also check the background code, like what code you have written, etc. and all, but many of them, you will be able to bypass it. 17 out of 29 test cases has passed, so that's a good number. You will be awarded mark per test cases. Okay, so let's say this is for 30 marks also, and every test case carries 1 mark. So you will be able to get 17 marks without even writing anything. Okay, that's something you can keep in your, but generally they will not be giving you any true or false related questions and all. So we need to go through it manually only. Now, how we can detect the cycle? How we can detect the cycle? Okay, let's talk about it. So see here, we have a very good algorithm and you will find it very funny. You see, linked list is generally very easy actually. Now, let me show you where is campus recruitment. Yeah. Just a second. Yeah, linked list cycle 2, that is. Done. Linked list cycle. Question number 141 it is. Okay. So given head of a linked list, we need to return if there is a cycle in it or not. That's it. Now, what are the constraints? We will be having somewhere around 10 to the power of 4 nodes. Okay, that's power 4 actually. Now, say this is the linked list that we have. Okay, and it has a cycle in it, as you can see here. It has a cycle in it. Now, if this linked list doesn't have a cycle, you will be coming across none. Okay, none. Now, how we can detect if there is a cycle? Okay, we have a very simple concept. We call it slow pointer, fast pointer, or you call it tortoise or hare technique, whatever it is. It is Floyd-Marshall cycle detection algorithm. Now, what we'll do is, the process is pretty simple. Imagine you are on a running race, you are on a track, okay? If a person is moving twice as fast as you, if a person is running twice as fast as you, what will happen means, if you complete 1 round, the other person will complete 2 rounds. Okay, so he will again circle you and match you back again. Okay, both of you will again meet each other. So this is a very simple technique that we are using. What will happen is slow will start from the head, fast will also start from the head. Slow and start are starting from the first node. Now, while fast is not equal to none, and fast dot next to not equal to none. Why did I write this one? Yesterday we have seen for even number of nodes and odd number of nodes, it is going to behave differently. Okay. So what I'll be doing is same thing. Yesterday, as we have seen in the middle of the linked list finding, so same thing. We will be moving slow 1 step, and we will be moving fast 2 steps. Okay. Again, slow will move 1 step, fast will move 2 steps. This process will keep on repeating until you come to the end of the linked list. Now, do we have any ending? No, we don't have any ending. So what will happen is, after a certain point, you see, as I said, a person is running very slow, another person is running very fast. If you have a connected path, if it is a racetrack, you see, it will be an oval shape or no, if it is a circle, he will again outrun him and he will again come back and join him. Okay, kind of like in Avengers movie, if you have seen. Okay, Captain America will say that to Hawkeye, na? So on your left. So in that manner, that's how it will be. So slow we have, fast we have. So did both of them meet each other? No. Again, you will continue. Okay, is fast equal to none? That means I reached the end of the loop, I'll stop. Or fast dot next equal to none means I have reached the ending, I'll stop. No, we did not have. So slow equal to slow dot next. Fast equal to fast dot next. Slow moves one step, fast moves two steps. Again, both of them, did they meet each other? No. Again, what will happen? Again, fast we have. So fast did not reach the ending, as you can see. Fast is not equal to none. Fast dot next equal not equal to none. Again, condition is true. So slow equal to slow dot next. Slow moves one step. Fast moves two steps. Okay. Slow moved one step. Fast moves two steps. Again, both of them did not meet. So condition is also not false again. Slow equal to slow dot next. Fast equal to fast dot next. Fast took two steps. Did not meet each other. Fast moves twice as fast as slow, and slow moves one step. You can see that. Again, both of them did not meet. Fast did not reach the end. Slow one step, fast two steps. Both of them did not meet. Again, condition is not false. Slow one step, fast two steps. Again, both of them did not meet. Fast is not equal to none. Fast dot next not equal to none. Slow moves one step, and see, fast moves two steps. Now, both are equal. Yes, both are equal. Both are pointing to the same node. So what does this indicate? If you have a connected path, generally fast is twice as fast as slow. So they should never meet. Okay, until and unless you have a loop, they will never meet each other. Okay. Now, both of them did meet each other. That indicates we have a loop. So whenever this condition is true, what will you do? You will be returning true. Okay, print true. Done. And we can break it here in functions and all. You will be returning it now. So you will be able to directly send it back. Now let's do this. Let's go with it. You see, what do I have to do is slow equal to, we will be going through slow equal to head, fast equal to head. Let me make it full screen and zoom in a little bit. Okay. Now, while fast is not equal to none and fast dot next not equal to none, while fast is not equal to none and fast dot next not equal to none, we need to keep on moving forward. Yesterday we have seen it. We have talked about all possibilities. So if you have missed yesterday's session, go back and watch it again in YouTube. Okay. While fast not equal to none, fast dot next not equal to none, what do we have to do? Slow will move one step. Slow equal to slow dot next. And how many steps fast will move? Fast equal to fast dot next. Okay. If you write fast equal to fast dot next two times as well, it is going to be the same. Okay. Nothing will change. Okay. Yesterday we have seen that one as well. Now, slow is moving one, fast is moving twice as fast as it. If there is no loop, fast will be the one who will reach the finish line. Okay. Either fast will be none or fast dot next will be none. Okay. If there is a loop, what will happen is, okay, if there is a loop, slow and fast will meet each other again. Fast will again circle back. He will be meeting slow. We just need to return true. If both of them meet each other, return true. If we don't have a loop, then it will end. Fast will be equal to none or fast dot next will be equal to none. We will come out of the loop. We will be returning, false. If there is a loop, we have to return true. If there is no cycle, we have to return false. That's it. This is the entire code. Okay. Now let's run it and then we'll not submit. We will check for hidden test cases. We'll talk about edge cases. Okay. How to determine them, how to identify. You see, for all of them, this is fine. Okay. Now see here, number of nodes in the list is will be in the range from 0 to 10 to the power of 4. Okay. Now linked list or in any other question, generally there is a high chance that you will be able to you are going to fail the edge cases. Edge cases means when the number of nodes are 0, when the number of nodes are 10 power 4 in that manner. So this is the most common edge case 0. So if I submit it now, there will be an empty linked list where I might get an error. Okay, for this we'll not be getting one because if you observe, slow equal to none, fast will be equal to none. Okay, if we don't have any nodes and all, head will be none only now. So we'll not even get into the loop. Fast equal to none. So we'll come outside, we will be returning false. So for this one, we are safe. From the next one onwards, you need to always check it out. Okay. So let's directly submit it. I'm confident we'll not fail any hidden test cases. Now see submitted 29 out of 29 test cases passed, 91 it is. That's a good number. Okay, so it's fine only. There are other ways of solving this as well. This is the linked list way. Okay, by using slow pointer, fast pointer. Other ways that you can think of is using a hash table. You can store all the visited nodes memory. If you have already visited it, then you can return false. Otherwise, you can return true also. Okay, you see linked list is there, 2 pointer. This is slow and fast pointer. Hash table is there. Let us use a hash table. Let us do it in non-linked list way. Let's say what I'll do is, people generally call it as scene. Scene is equal to, I can take a list or I can take a set. Okay, so let me take a set. This is a set. This is how we declare empty set. Now, while fast not equal to none. Okay, while current we will say, sorry, my bad. And we don't even need the head of the linked list, so that's also fine. If you use head, current equal to head, while current not equal to none. Okay, until I have a node, I'll be storing its address inside scene. So what I'll do is set dot add of CRR. I'm adding its address. Okay, when I'll add its address, if it is not present in my set, so if CRR not in set, okay, what is that set name scene? If I have not gone through this memory, then I'll add it. Okay, if I have seen it already, let's do one thing. If CRR in scene, then we have a loop, right? So we will simply return true. If CRR is not in scene, then automatically this will be executed. Now, if I have not seen it and I have added everything and current became none, I'll come outside the loop. I'll be returning. There is no cycle here, so return false, right? So let's run this out. Let's check it out this time. The earlier one was slow fast pointer. This one is what we are using. Sector check does not support apply to a list node. Okay, we need the memory. What should we do? Let's try it as a list also. Sorry. Yeah. Fine. I understood. This is scene actually. Okay. Fine. Run it. Now let's see. One test case failed. One we have expected. Sorry, I did not even move current as well. So current equal to current dot next. My bad. I was not thinking much. So I've initialized the empty set, started current from the head. While I have nodes, I'll keep on moving forward. I'll be storing this address that I have seen inside a set called scene. If current is present at a node which I have already seen, then there is a loop, I'll return true. Otherwise, I'll come out of the loop, I'll be returning false. Okay. Now that's it. Now run it and submit it. That will be fine. Now let's run it. Okay, all the test cases are passed. Now submit it. This is one more way. This is by using hash table. Okay. As I said, for a given question, you need to go through multiple ways of solving. Okay. You can open the topics tab here, or you can even go through the solutions. Even if you do 1-2 questions per day, let's say you have an year. Okay. Even if you do 1-2 questions per day, this manner, if you solve 500 questions or so, not even 500, the blind 150 properly, you will be able to solve any given question. Okay, so understood this one? Any doubts in this one? How did you like it? Understood this one? Any doubts? Any doubts? Any doubts? Any doubts in this one? This is the second solution. The first solution we have seen is this one. Okay, this is the first solution. You can note down both of them, or you can take a screenshot of this if you want. Slow fast pointer is one technique, and we have used a hash table as well. Done. Now let's go through cycle detection 2. You see, this is cycle 1. Let's go through cycle 2. Okay, and let me remove the code as well. Yeah, code is already deleted, so that's fine. Now see, I have taught you cycle 1. I want you to come up with the answer for cycle 2. I'll be making the messaging to host and co-host. I said, given any written exam, you will be having 30 minutes, 45 minutes per question. Okay, this is a medium level question, not so easy as the previous one. Okay, you can see the acceptance rate 57. Anything above 60 is fine to solve. Below 60 is a bit you need to think about. Same thing, given head of a linker list, return the node where the cycle begins. If there is no cycle, return null. We need to return the head of the node where, we need to return the address of the node where the cycle begins. If there is no cycle, return null. Now we know half of it. You have already seen half of the solution. If there is a cycle, you know how to detect it. If there is no cycle, you will be simply returning null. Okay, done. So null in the sense none in Python. So you'll be simply returning none. Now we should not modify the linker list. How do I know? How can I know? In the linker list way, like in the hash table way, you will be able to solve it easily. You see, if I go through the topics, we'll have 2-pointer. We'll be having a hash table. It's the same thing. Okay. In the hash table way, you will be able to happily solve it. Or hash table, I'll just copy paste it. I'll be able to come up with that. Let me click on it. Okay. Hash table, we have seen this now. Let's copy this part. I'll again, where is it? I'll again come back here. You see here, if I save it, okay. If I have seen it, so I'll be returning current. If I have not seen it, I'll be returning none. By default, it will return none, so we don't even have to do that. Now run it, and you can submit it. Cycle detection 2 will be also done, but I want you to do it in 2-pointer way. Okay, I want you to do it in 2-pointer way. You see, 18 out of 8 passed. So first one will work, but I want you to detect it in 2-pointer way. This is a very interesting question. Okay, I recently had a small brainstorming session on this one as well. So I'll be eating your brains as well today by explaining it. Done. Now, say this one. You have how much time left? Let me reset the timer. Let me reset the timer. I've given you one answer. I am expecting the other from your side. Okay, let me reset the timer. You have 5 minutes. Think about it. Linkerless cycle detection 2. Think about it. Think about it. Think about it. 142. 142. You need to return the address of the node where you have a cycle. Where you have a cycle. And I'm expecting some sort of explanation or answer from your side. So I'll be waiting for it. I want you to think. It's not like I'll be explaining the question, I'll be explaining the answer, then you're not going to learn anything new much. You will not be gaining much from it. I want you to try and come up with some sort of solution, some sort of algorithm for it. Okay. Right, so you have 4 more minutes. I'll be waiting the entire time. Okay. So let's see. Let's see if we can get anything. Guys, no response from anyone. Okay, we'll stop it here. Let me give you some hint, or let me take you up to some part. Okay, so let's say we already have a linked list. Okay, question number 142 it is linked list cycle reduction 2. Done. Now, now let's say this is the linked list that we have. Okay, and we already have a cycle in it, as you can clearly see. If we don't have a cycle, obviously it will come out of it. We will be able to go through that. Now, how can we detect if there is a cycle and the starting point? Okay, you already know half of the answer. What's the half of the answer? Half of the answer is we will be having a slow pointer, we will be having a fast pointer. We will move slow pointer one step, we will move fast pointer two steps. Okay. If both of them meet at some point, we have a cycle. So let's do that. You see, this is the head of the linked list. Slow equal to head. Okay. Fast equal to head. Slow and fast are pointing to head. Now, while fast is not equal to none and fast dot next is not equal to none, while I did not reach the ending, okay, if we have a cycle, we'll never reach it. Now we don't reach because we have a cycle. Slow will point, like so will move one step, fast will move two steps. Slow moves one step, fast moves two steps. Now again, slow will move one step, fast will move two steps. Okay. Again, both of them did not meet. So as of now, no cycle, not detected. Slow moves one, fast moves two, slow moves one, okay, fast moves two. Again, slow moves one, fast will move two steps. Again, slow pointer, fast pointer did not meet. So we did not reach the end. Slow will move one, fast will move two. Let me fast forward a little bit. I've already seen this part, so slow will move one, fast moves two, slow moves one step, fast moves two steps, slow moves one step, fast will move two steps. Now, slow moves one, fast moves two. Now the last iteration, slow mode one, fast moves two. Now we know we have a cycle. Okay. When you have a cycle, what we will be doing is We know the cycle detection point, that is one place. Again, we will be starting from the head. You see slow pointer, I'll take it, I'll start it from the head. Okay, slow equal to head. Now, the distance from the cycle detection point and the distance from the head is actually equal. Why it's equal? We'll do some math as well for it. Okay. So for now, when you detect the cycle detection point is 70. From 70, if you are moving one step at a time, and from the head, if you are doing one step at a time, okay, both of them will again meet at the cycle starting point. Let me show that to you. You see, while slow and fast are not equal, slow moves one step, fast will move one step. Again, not equal, one step, again, not equal, one step, again, not equal, one step, one step. Okay, that's it. Both of them did meet each other. So this is the cycle starting point. So we will be returning slow. Let's say you don't even have a cycle. So what will happen? You will automatically come out that outer while loop and you will be returning none. So that's how it will be. So we don't have to check that test case anyway. You already know that. So let's do it. Let's code it out. Then we will talk about how actually it's working. Okay. Now this should become a drill. This is the third time I think we are writing it. So this should be fairly easy for you. Now see here, I'll go with slow equal to head, fast equal to head. I'll zoom in a little bit and maybe we'll place it to the top. Yeah. While fast not equal to none and fast dot next not equal to none. If you did not know why I'm writing this, go back and watch yesterday's video where we have been discussing about the middle of the linked list question. You will understand it. This is one point. Next, slow will move one step, slow equal to slow dot next. Fast will move two steps, fast equal to fast dot next dot next. Okay, fast moves two steps. Now, if slow and fast meet each other, meet means we have a cycle. When you have a cycle, what did I tell you? The distance from the starting point, okay, of the linked list and the node where the cycle is there, they will again meet at the loop starting point. Okay, they will again meet at the loop starting point. So start slow from head again. Okay, so you are starting slow from head. Now you will be checking if slow not equal to fast. Okay, slow will move one step forward, slow equal to slow dot next, fast equal to fast dot next. Both of them are moving one step. Now both of them are moving one step. When they meet each other, sorry, while they did not meet each other, go one step. When they meet each other, then you will come out of it. You can either return slow or fast, your wish. So return slow. That's it. Now, if we don't have a cycle, we'll come out of it. So we will simply return none. Okay, we'll simply return none. That's it. Now let's run it. Let's see if there are any mistakes. We'll correct them. Otherwise, we'll submit it. Done. All sample test cases passed. Now submit it. Everything fine. So you see here, we are getting 19%, which is very bad actually. Now let's try to submit it once again. 29% this time. What are they doing for the 0%? Yeah, 0% also, you see, this is 0%, 0 milliseconds in the what? It is also the same. It's also the same. Maybe because they have written a single one or double. If they don't have one, they have written this one. But anyway, our solutions are same. Depends on internet speed sometimes. You see 70, 19% again it is not. Fine only, but this is the correct code. So this is the most optimized ones. Done. 18 test cases only you have. That's it. This is about cycle detection. Now let's go back and talk about how it will be equal. Okay, why should I start from head again, and what's the theory behind it? Okay, let me show you some math. I know students generally don't like math, but fine. Okay, we'll talk about it anyway. Yeah. So now see, now this is the starting point of the cycle. Okay, imagine the length of these nodes is A. Okay, and the length from the cycle to the starting point, like from the meeting point, is B. This is what we call B. And the cycle itself, we'll call it C. You see this entire thing we have now. Let me change the color of it, color of both of them, maybe. Okay, this is A. Now for cycle, I'll be going B. Okay. Let's say the entire cycle, what we have is C. That in that cycle, a small part of it, maybe from the starting point to this one. This is B. Okay. Done. Now, see some equations will be coming here now. You see, how much distance did slow pointer travel? You see, slow pointer traveled all the way from 10, 15, 25, okay, etc. and all to 70. So the distance traveled by slow pointer is A plus B, right? Distance traveled by slow pointer is A plus B. This is the slow pointer travel. How much distance is the fast pointer travel? So say fast pointer has traveled A, and fast pointer has gone through the entire cycle once. So A plus C. Fast pointer again came back and joined with B. So it has traveled extra distance B. So A plus C plus B. Okay. And in my presentation, it did meet it at one circle. Okay. At one cycle. It could be 2, it could be 3, maybe it could be any cycles. It doesn't matter anyway. So if you observe, this is A plus B, this has traveled A plus C plus B. Now, according to the theory that we have, you see, fast pointer moves how much faster? 2 times faster than slow pointer, right? 2 times faster than slow pointer. Now, if you equate both of these two equations, you see, fast is A plus C plus B, right? And slow is A plus B. So this is equal to 2 times A plus B. Done. Now, A and A will cancel out each other. So you see, we have 2A and we have 2B. So we have this A, B cancel out. So what we are getting? A plus B equal to C we are getting. And what is the distance that we are interested in? Okay, we want to know this particular distance, that is C minus B. So A will be equal to C minus B. So whatever cycle that you have, in that cycle, if you subtract B, this is the remaining length. You see, this is the remaining length. Okay, from this cycle, like from the loop starting point up to the from the meeting point of slow and fast up to the loop starting point. So that will be equal to, in this entire cycle, if I subtract B, I'll be having that remaining length. That will be equal to the distance from head to the cycle starting point. Okay, A equal to C minus B you're getting. Done. So that's why if I'm starting slow from the cycle meeting point and again from the head, they will be meeting at, if I start one pointer from slow and fast meeting point, cycle detection point, and the other one from the head, they will again meet at the starting point of the cycle. Okay. Now imagine there is a situation, let's say I'm clearing all these drawings. There is a situation, let's say 50 is connected to 40. Okay. Ignore all the other part. Let me try to make it as big as possible and erase all of this stuff. Okay. What's this? Smart pen it is, highlighter it is, vanishing pen. Okay. Let's say we don't have any of it. Let's discuss one more scenario. Okay. Let's discuss one more scenario. We don't have any of this. And so imagine we don't even have it. Imagine we don't even have it, and this is the cycle. Okay. Now, 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 even if you do the same, let's say slow pointer, fast pointer are starting. Slow pointer moves one step, fast pointer moves two steps. Slow pointer move one step, fast pointer move two steps. Slow moves one step, fast moves two steps. Slow moves one step. Again, fast will move two steps. Slow moves one step. Fast will come here. It will again come here. Fast moves two steps. Slow moves one step. Fast moves here. Okay. And sorry, fast will move here. Okay. Again, slow moves here. Fast will come here. Slow moves here. Fast will come here. Okay. And slow will come here. Maybe we'll take one more thing, just not to confuse you. Oh shit, it all erased. I gave it in a single stroke, it seems. Finally, we'll draw this part. Let's say we don't even have any of this. Okay. We don't even have any of this, and done. Now this will be good. This will be good. Now we have it again connecting to 40. Let's do some tracing. Let's do some tracing. So this is slow. This is slow. This is fast. Okay. Slow. Fast moves to. Slow. Fast moves to. One step. Two steps. One step. And again, if you observe, two steps. One step. Again, two steps. One step. And fast moves two steps. One step. Fast moves two steps. One step and fast moves two steps. Okay. So again, slow and fast met each other at 50, right? So now what we are doing is we are again going to start slow from. We are again going to start slow from the starting point of the linked list. Starting point of the linked list. You see here, this is the meeting point for both of them. Now fast will stay here, slow will be here. Slow moved one step, move fast one step. Slow moves 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 one step, move fast one step. Again, they will meet each other at the starting point of the loop. Okay. So how it works? As I said, fast is 2 times faster than slow. If slow is covering A plus B, fast will be covering, this is slow. Fast will be covering, okay, A plus cycle, N into cycle plus B. That N cycles can be anything, okay. It can keep on rotating there until they meet each other, okay. So what happens is, as slow is again starting from the beginning, by the time it comes here, or whatever the multiples, what is the length of the loop here? How many cycles you have? What is the length of the loop here? What is the length of the loop here? The length of the loop is You see, 1, 2, 3, 4. We have 4 values. Okay. So it's kind of like whatever multiples of 4, whatever length of A that you had. Okay. What is the length of A? 7. So 7 is A. A modulus C. What is A modulus C? 7 modulus 4. You will be getting 3. Okay. So 3 in the sense, after going through 4 elements, we only have these 3. Okay. So even if I start my slow from here and fast from here, they are going to meet at the cycle starting point. This is slow will be here, fast will be here, slow will be here, fast will be here. So whatever cycle that fast generally keeps on rotating, it's kind of like useless. Let us say we have 100 nodes. Okay. Let me delete all of it. Let me delete all of it. Let me delete all of this. Yeah. Let's say you had 100 nodes, okay? And the cycle that you have is 98, 99, 100. 100 is again meeting back to 99, okay? This is where you had the cycle. Done. So how many values you have in your cycle? How many values do you have in your cycle? What is the length of your cycle? Cycle length is 3. Done. Cycle length is 3. Now, when they meet each other, okay? When they meet each other, I think they will be meeting at 99 or 100. You can use ChatGPT to check it out also. A length is 97. 97 nodes is where we don't have the loop. This is A length. Okay. Coming to cycle length. Cycle length is 3. Done. Cycle length is 3. Now, cycle length is 3, and they both will meet each other here. Okay. You can also check it out. You can do it manually. You can also ask ChatGPT. This is the meeting point. This is where slow and fast will be meeting each other. Okay. Now what will happen is slow will start from the head, means here. Slow will be keep on moving all 97 nodes. And if you observe, the fast will also move one step. So if fast moves 3 steps, means fast moves 1 step means 98. 1 step means 99. Another step means fast will stay in the same position. So if A moves 3 steps and if fast moves 3 steps and slow moves 3 steps, they will be exactly at the same position. Fast will be exactly at same position only. Okay. So let me show that to you manually. C equal to 3. A reaches 3. Sorry, not that one. A is 97. 97 nodes we have, which is not a part of the cycle. We will be moving up to 3 nodes. Fast will be exactly the same place. Slow will move to 6 nodes. Fast will exactly stay at same place. A will keep on moving to 9 nodes. A will be moving to 12 nodes, 15 nodes, so on up to 96 nodes. Multiple of that cycle. Okay. So even if my slow pointer is at that 96, okay, up to 96, fast will be at the same place only. Now when it moves back to 97, this is where slow is, this is where fast is. The length after removing that modulus, all the multiples of cycle in it, will be equal to the length, okay, from where they both meet each other, right? If you find all this too complex, just relax back for some time and do that math calculation, or simply you can remember for now, okay, whenever slow and fast will meet each other, the distance from their meeting point to the cycle starting point is equal to the distance from the head to cycle starting point. So once slow and fast meet each other, what you can do is you can happily start slow from the beginning, okay, and fast from the meeting point. You can move 1 step until they both meet each other. You can take any number of illustrations, you can take any number of examples, they both will meet each other. It's all basic math only. Once you do that math, like 100 I have given you now, you can ask ChatGPT the same. That will give you calculation, that will give you good formulas, etc. and all. If you go through it, you will be able to realize it. Okay, that's it. That's about cycle detection too. You will be always able to detect the starting point of the cycle in this manner. Okay, or the other way we have also seen. What is the other way? We can also use a hash map or a hash table. You see this one? This is the hash mapper. No? Let's go with this one, 27 minutes maybe. This is where the hash map is. Done. This is one solution. Let me copy this. I'll go back to our code. This is the other solution. Done. So we have two solutions for this one. You can take a screenshot of this one as well. You can solve a question in multiple ways, and learning a question means learning all those ways and learning how generally things work. Okay, with that example or with that details, you will be able to solve any given question. Done. That's it. That's about cycle detection too. So, any doubt in this? Any doubt? Do you want to talk about anything? Any doubt in cycle detection too? Or we are good to go? Any doubt in cycle detection too? Any doubt in cycle detection too? Okay. Let me know if you are still facing any issues also. Okay. Okay. Let's go back. Let's talk about the reverse of a linked list. Okay. Reverse of a linked list. That's one more important question. Kind of like a model for us. Okay. Model question it is. Let me click on it. Let me remove all the previous code if there is any. Yeah. Now, reverse of a linked list. You see, given a linked list, return the reversed list. So, can you come up with any ideas about how to reverse it? You see, there will be 5,000 nodes that you have. Okay. How to reverse it? Any ideas? Any ideas from your side? Given the head of a linked list, return the reversed linked list. Return the head of the reversed linked list. Okay, tail dot next equal to head. That is going to become a circular linked list, na? Kushi? That's not correct. If tail dot next equal to head, that will become circular, and we need to find tail as well. They will not be giving us tail anyway. Any idea how we can reverse it? Next pointer, previous pointer, yes, very close, very close. We will be able to reverse it in that way. Okay. You see, one way of reversing is we can create a new linked list. We can create a new linked list. Okay. First, you need to traverse through the entire linked list. You need to find the length of it. Okay. Then you need to again what you say, or you can access the first value. You can kind of like perform insertions at the beginning. Let me do the other way. Then we will talk about the optimized way. You see, my logic is pretty simple. Reverse means the first node here will be the last node. So what I'll do is I'll access it by using current. and I'll take another linker list called reverse. Initially, it is pointing to none. So the first node I'm accessing, the value is 1. So what I'll do is, I'll make this one more node. I'll create a new node. The value inside new node will be 1. Now, this is what I'm performing. I'm performing insertion at beginning. So this is going to be my reverse head. Now again, I'll insert it at the beginning. I'll keep that value of the node as 2. Now this is my reverse head. Now same thing, I'll access 3, I'll insert it at the beginning. Okay, this way I'm creating a new linker list. Now let me do that. Let's do that. You see, first I'll take current equal to head. I'm starting from the head, while current not equal to none. Current equal to current dot next. I'm accessing all the nodes of my linker list. Now, as I said, reverse head. I'll take reverse head is equal to none. Okay. I need to create a new node. And how to create a new node? I think the object creation is list node here. So you see, new node is equal to, okay, list node of, I need to create a new node with the value. I can even send the value. So with the value of this current. So current dot value. This creates a new node for me. Okay. You see, I'll write it here as well. New node is created. Now I need to insert this new node at the beginning of my reversal linker list. So what I have to do is, so again, I think insertion at beginning now. Yeah. New node dot next is equal to reverse head. Okay. Now how I'm writing it, I'm visualizing it in my brain. You see, current is present on 1. The reverse is pointing to none. Okay. I've created a new node, and the value inside that is current dot value. You can see I'm sending it as well. This is how we can create it. The class names and all are equal. If you don't know about object and class, you need to wait for some time. You need to learn them. You will understand this eventually. Now I have taken this one. This is my new node actually. New node should be pointing to the reverse. Okay, that's what I did. Reverse head. Okay. And current will move on to the next one. Now next time I'll create another new node with the value 2, with the value current dot value. This is the new node. This has to point to reverse dot head. So reverse dot head I need to update. So insertion at beginning only this is. Okay. So here reverse head will be equal to new node. Right. So now this will keep on repeating itself until I have completed all the nodes. And when I come out of it, I just need to reverse and I just need to return this reverse head. Okay, don't worry. We have explanation coming up. My visualization will be always there. Okay, this is what I do in my mind. Our mind is much more powerful. Okay, these all things, iterations and all. Once you practice it, that will be easy. You see, I've submitted it. This is one way. But here, if you observe, my space complexity has taken a hit. Okay, because I'm creating an extra linker list of the same length. I'm using extra space. I'm creating new nodes now. Okay, we can submit it even better. We can even do better. So let me copy this. I'll be pasting it here. Now let's do even better. Okay. Let me show you how we can reverse the original list without using or without creating another new linker list. Okay. Now this is lead code question number 206, where we will be reversing the original linker list. Okay. Now see here. This is the linker list that we have. Okay. As I said, this is the head of it, and current is pointing to head. Done. Reverse head is pointing to none. Let me close everything else. I'll keep it on the top as well. Now, while current is not equal to none, is current equal to none? No, I'm present on a node, so that's fine. What I'll do is, I'll be using another pointer called next. Why I'm using? Let me tell you that. And do not be confused by dot next and next. Dot next is a instance variable. So next is a normal variable. If that confuses you, I'll be reading next as after. Okay, both are two different things, so don't be confused by it. It's current dot next, not next. So next equal to current dot next. Next will be pointing to the next node that I have to reverse. Why I'm doing it, I'll explain it in the second iteration. Now look here. Now, in order for me to reverse it, initially 12, 4, 61, 29, 40 we have. If I reverse it, okay, 40, 29, 61, 4 and 12 we will be having. Or the first node becomes the last node, okay, or the first node will be pointing to none. So 12 will be pointing to none, okay, or I'll already have this node. So what I'll do is, I'll make current dot next is equal to reverse head. So current dot next is pointing to none. Done. Very good. Now see your reversed linker list. On bottom you have reversed linker list. On top you have original linker list. Reversed linker list earlier did not have a node. You see it is pointing to none. Now you have a node. So who is going to be the head? 12 should be the head. So that is nothing but reverse head. So reverse head will be equal to current. So reverse head, earlier it was pointing to none. Now it is going to point to current. Now I have reversed one node. Now I need to access the rest of the linker list. Now, if I did not place this pointer here, you see if I did not have this, why I'm having it? If I did not have it, I would lose the access to the entire linker list. I'll never be able to access that one. So that's why I have stored another pointer called next here. Now what do you have to do? Same process, you just need to repeat. Current equal to next. So current will again go back to the starting point of the linker list that you have. Okay. Again, you have a node, current is not equal to none, so you can reverse it. First, I'll be marking the rest of the linker list. So next will be pointing to 61. Current, whatever I had, that should be the second last node. So it should be pointing to the last node that we have. Okay. So current dot next will be pointing to reverse head. So current dot next points to reverse head. Now in your reverse, how many nodes are there? Two nodes. Who is the starting node? 12 or 4? 4 is the starting node. So reverse head is equal to current. Okay. Now again, the cycle will again start. So which node you have to, okay, again reverse 61. Do you have access of 61? If you did not have next, you would not have access of the rest of the linker list. So again, we had next, we have pointed it out. Again, current will go back to next, current equal to next. Current will go to the node where it has to insert, like where it has to connect it. So current is pointing to 61. Current is not equal to none, it's pointing to a node. So I'll keep a track of the rest of the linker list. I'll take the current node, I'll point it out the reverse head. Current dot next equal to reverse head. Now the same cycle. The first node is 61, reverse head equal to 61. Current node that you have to reverse is 29. Current equal to next. Same process, rest of the linker list I need to have access of. So next will go there. Current dot next will be equal to 61. Okay. Reverse head is equal to current. Current equal to next. Current is not equal to none. We have a node, so we can reverse it. Next will go and point to the rest of the linker list. Current dot next is equal to reverse head. Okay. Reverse head is equal to current. Now current will go back to next. Now do we have a node? No. Current is equal to none. Current is not present on a node. So I cannot reverse anything, or I have reversed everything. Okay. That's it. You will come out of the loop. And which one do you have to reverse? Like return. I have to return reverse it. Right? Understood animation? Do you want to see it again, or this is fine? Do you want me to show it again, or this is fine? Understood this one? Do you want to see it again, or this is fine? Do you want me to show this again? I've set the meeting chat enabled to everyone. Hello? Do you want me to show this again? Okay. Let's go back. This is it. This is reverse head. Current is pointing to head. Reverse head is pointing to none. I don't have any reversed linked list. While I have nodes, while current is not equal to none, while current is on a node pointing to address, I'll keep a track of the next node. I'll remove this node. I'll reverse it. Okay. Now in your reversed linked list, you have one node. So reverse head should be equal to current. Reverse will be pointing to 12. Now current will again go back. It will bring one more node to me. Current equal to next. Current is not equal to none. I have a node. I'll mark the next node that I have to reverse so that I can come back to that point. Current dot next equal to reverse head. Okay. So reverse head is equal to current. Current equal to next. Okay. Again, current not equal to none. Next, I'll point it out. Current dot next equal to reverse head. Reverse head is equal to current. Current equal to next. Current not equal to none. Next, I'll point it out. Next equal to current dot next. Current dot next will be equal to reverse head. Reverse head is equal to current. Current equal to next. Again, current not equal to none. Next is equal to current dot next. Current dot next is equal to reverse head. Reverse head is equal to current. Current is equal to next. That's it. Current not equal to none. False. Comes out of the loop. Returns the reverse head. That is the head of your reversed linked list. Okay. That's it. You can watch it as many times as you want on YouTube. Now coming back here, okay, you have the visualization in your brain. So at least why I'm showing you all of it is when you're writing the code, you can follow it up in your brain only. Okay, we will be able to write the next lines here based on that. So as you have seen, first I'll take current equal to head. I'll take reverse is equal to none. Now, while current is not equal to none, while I have a node, I need to preserve the next node's address so that when I'm breaking the link, I could again come back and reverse the remaining part. So, what do we have to do? We simply have to go with next we need to take. I'll take it as after node. After is equal to current dot next. Okay. Now, current dot next, I'll break the link. I'll point it to reverse. Now in reverse, this is the new head I have, or we'll take it as reverse head only. Reverse head only. That's a good terminology. It will make it readable. When you read it, your brain will sync all the things. Means after coding for 2, 3, 4, 5 hours, will not have the same concentration. So if it is readable, our brain will do the visualization. It will subconsciously give us the answer, even if you are not concentrating much. Okay. So reverse head is equal to again current. Okay. I'm imagining that reverse head came back. It's pointing to current. Current is below in the reverse region. Current should again go back to the next node that we had to reverse. So current is equal to after. Current went back there. Whatever PPTs that you are seeing is actually what happens in my brain. So I'm showing you what's inside my brain. Okay, to be honest. That's it. This process will keep on repeating itself until everything is reverse. And what do we have to return? We just have to return reverse head. That's it. Now, are we using any extra space here? No, we are reversing the original list. So this one is better than the previous one. Both are valid answers. You can even create an entirely new linked list, or you can even reverse the existing one as well. So reversing the existing one will be faster, will occupy less space than the previous one. Now I'll run it, then I'll submit it. Okay, run it, submit it. Let's see how it goes. Okay, space complexity should be high, definitely. You see 50% more faster, right? Earlier it was 5. If you submit it again, it will be even better, mostly. Fine, we don't have to think about it too much. But you got 2 different approaches, okay? Two different approaches. Take a screenshot of this. Can we close this question then? This is two different approaches. And as I say, whenever you are studying a question, it's not like you submitted it, that's it, done. You have copied, pasted it from ChatGPT, you have listened to your YouTube lecture, you have done it. No. You need to do it entirely on your own. Brainstorm yourself. Ask ChatGPT for hints without revealing the answer. Make it as your coding mentor. Okay? You can watch all our sessions from the beginning, maybe another time. That will help you to absorb each and everything that I am giving you here. This is a very good boot camp for you, okay, to get started with your journey in data structures and algorithms for product-based companies. You will be happily get able to get a 7+ LPA, okay, even after going through all these 30 hours of content and with a little bit of practice. Done, done, fine. Everything is good. Good. Can we go to the next question, or do you still have any doubts in this? Any doubts in this? Any doubts in this? Any doubts in this? Fine, fine, fine. Done. Now let's go through the topic of dummy node. Okay. Let's go through the topic of dummy node, and there is an assignment for you. There is an assignment question for you. Okay. There is something called palindrome linked list. Okay. So you need to complete that question. That's your assignment question for today. If you do that entirely on your own, okay, without the help of anyone, and if you come up with the optimized way, then you are in a very good path. So question number 234. This is your assignment question. This is your assignment question, that is palindrome linked list. That's your assignment question. Palindrome linked list. Yeah, it's already in YouTube, so you can happily get it. Okay. So I've paused the screen for 10-15 seconds now. So again, watch back in YouTube, take a screenshot of it, you'll get it. And I don't think I have it here. Maybe I'll press on reverse. Okay. 234 is your assignment. Let me go back. One student wants to see the previous code. Yes, this is the previous code. Take a screenshot of everything if you want. Done. Done. That's it. Now let's go back to one more model. Reverse is a model. Cycle detection is a model. These insertion, deletion operations you have seen, these are simple questions, simple model accessing. That's a model. Now let's see the removal. Remove duplicates from a software list. Let's see this one. This is an easy level question, but this is going to be a bit difficult for you. Yeah. Okay. So question number 83, this has an acceptance rate of 56. Anything below 60 is a good question. Okay. So given the head of a sorted linked list, delete all duplicates such that each element appears only once and return the sorted list as well. Okay, we need to remove all duplicates such that we will be only having unique elements. You can see that. Okay. They will be giving you the head. You need to return the head of the sorted list. Head of the sorted list. Now see how you can do that. See how you can do that. Try to come up with some sort of scenario. Okay. to come up with a way of solving it. Done. So we got some message. What's that? Let's check it out. If it is, can we use a set to remove duplicates? Yes, that's also fine. Okay. I want a solution. You can use any other things that you know. Okay. First thing is, given a question, you should come up with an answer. It should satisfy all the test cases. Okay. Second thing, we will talk about optimization. Okay, and then we will talk about the linker list. We are learning linker list. In this linker list, how we can solve it without using any set, any other data structures also. The linker list way we will see, because when you are in an online assessment OA, the interviewer will ask you, okay, if you are using set also, that's okay, but the interviewer will ask you, I want it to be specifically done in linker list way. I do not use any set also. You should know multiple approaches. Okay. So try to come up with one scenario, then we will talk about the other ones. Then we will talk about the other ones. Set plus CRR and previous pointers did not get you. You see, I can think of having one, two, three different ways. Three different ways of solving it are there. Okay. There are three different ways generally. There are three different ways of solving it. There are three different ways of solving it. You have 2 more minutes. I'm expecting some sort of answer from your side. Okay. Right, so 25 seconds more. 25 seconds more. Adding each unique element value to a set. If a value is already in the set, remove that node. Okay. Okay. You can take your time in implementing it, removing the same kind of numbers. Yes, it's easy to talk about, but when you actually do in linker list, that's a bit difficult if I have to talk about it. Okay. So it's easy when we it's easy when we just generally discuss it, but I would like you to go through it. There is a similar question for this one as well. Remove sorted link, like remove duplicates from sorted list too. That's your another assignment. That's your second assignment. You can check that out as well. Okay. Now coming to this one, see, what I will do is I'll create another new linked list. That's one solution. Linked list way only we will do. We'll create another new linked list and we will return that head. You see, new head is equal to none. Initially, I don't have any new linked list. Now current is equal to head. While creation, I hope everyone have seen it. Okay, the animation and all. While, let me write it properly. Okay, while current not equal to none. Okay, while current is not equal to none means I'll be having that many number of nodes. Current equal to current dot next. I'm accessing the first linked list. First linked list I'm accessing. Now what I'll do is I'll add the first node here. Okay, so if new head is equal to none, if your new linked list is empty, you can simply add the first one. Okay, so we can create a new node, we can add it. So let's create a new node. So list node is the syntax to create a new node. Inside this node, the value will be equal to current dot value. Okay, so that's the value that we are having. This is the new node. New node is equal to list node of current dot value. Done. I've created a new node. Then this node becomes my head as well. So maybe I think, yeah, we will cut it out. We'll paste it here. We have created a new node. If new head is equal to none, then the node that you have created is going to be your head node. So is equal to new node. Okay. And we don't have any tail. If we take tail, that will make things easier for us. So tail equal to none as well. Okay. That is our head node. That is our tail node. Tail equal to new node. That's it. If it's not equal to it, okay, if it's not equal to this one, then I need to check when I have to insert it. Like the first element is inserted. For the second element, you see, I'm still getting one. Okay, you see here. Let me show you some visualization of what's happening in my brain. Okay, this is current. I've accessed the first one. I've created new node. Okay, this is value is one. Now this is our new head as well. Right. This is done. So current equal to current dot next. Current comes here. Should I add this one? No. Why? You already have it. You already have it. Now how can I check it? This last value is pointed by tail. Since they are saying this is a sorted linked list, this current should not be equal to the tail node that I already have. When they are not equal, then only I'll be adding it. So the new node is created with the value one. Okay. Then what I'll do is I'll check if tail dot value is not equal to, if tail dot value is not equal to current dot value, then only I'll be adding that new node. Then only tail dot next equal new node, then only tail will become a new node. Head will not change. Head should always point node only. Tail will keep on changing. Okay. The new node that you have created, you will add it at the ending of it, and tail will become equal to that new node. Okay, that new node becomes tail. Done. The same thing in creation. If you missed it, watch the yesterday's lecture. Starting only we have discussed it. We have added a small thing. When I'll be adding that new value, if it is not equal to the tail value, right? Now, once we are done with everything, they told us to return the new head. Let's see if this works or if there is any error in it. Let's see if this works. Let's check it out. Run it. Submit it. Let's check it out. Check it out. Yes, 28.53%. It is slow because you are creating a new node every time. We don't even have to create a new node. We can use the existing node only. Okay. We can use the existing node only. We can share the existing node only. Yes, you will slowly. Once you spend some time, once you do everything on a piece of paper, Kushi, you will be able to slowly think about optimized solutions. Okay. Now, logic building or evolving your brain is kind of like you need to continuously get into it. Okay, pick up the question, think about it, do some brainstorming. So you will be able to slowly get into that zone. Okay, once you are used to it, everything will be fine. So this is one way. We can also do it easily. So let me show you some animation if I have. So what do we have? That is remove nodes, not start nodes, start nodes, interface, middle node, cycle, cycle, cycle. Let's also see delete nodes in linked list. Let's see this one. Delete a node in linked list. Please. What's the linked list question number? 83. Remove duplicates. Let me check it out in my drive. Remove node we have, delete node we have, remove nodes I think we don't have. Yeah. Sorry, remove nodes we don't have it. But anyway, I'll show you by visually drawing it. Okay, I'll show you by drawing it. Done. Now see, this is the first node, second node, third node, fourth node, fifth node, sixth node, seventh node, eighth node. Okay, 40 only. Ninth node, 10th node. That's it. This is pointing to 9. Okay. Now, what we have to do is we will be using a concept called dummy node. Let me write about it. Dummy node. Now, what is this concept of dummy node? You see, when you need to think about using dummy node is whenever we will be repeatedly changing the head value. Okay, we can also go without using dummy node, but we would have to write if else conditions and all. So whenever we have to repeatedly perform or repeatedly change the head, repeatedly change the head. If you think your head can change, okay, means you see, is this going to be the head or is this going to be the head? Is this going to be the head? In this manner. Okay, if you think there will be a change in head. In the next question, you definitely have to use dummy node. That's why I'm telling you in this one only, because as I said, next question is the assignment that you have to do. Whenever we want to repeatedly change the head, you need to think about using dummy node. Okay, and yeah, repeatedly change the head, or if you think the head will be removed. Okay, if yeah, repeatedly changing head also same. This one point, okay, you can remember that one point. There are other ways of writing it, but not needed. One point will be more than good enough. If you want to change this head, maybe 10 if it's not the head, 20 can be the head, 30 can be the head in that manner. If you are performing any operations at the starting of your linked list, think of using dummy node here in this manner. That will help you. Okay. Now let's see what we can do. What we will do in dummy node is we will create a new node. This is called dummy. As the name indicates, it's dummy. Okay, dummy. Dummy will be pointing to the linked list. Okay, so this is our head. So what I'll do, dummy equal to list node. Okay, dummy dot next equal to head. This is what I have written. Now this is the result of it. Everything you need to do it in this manner only. This is how I done it. Okay. Now what you have to check is we need to see if these two values are equal or not. So we will take a current pointer. We will take the previous pointer. That is where dummy is present. Okay. Now current and current dot next are both are equal. Okay. Yes, current is equal to current dot next dot value. Okay. Or what else we can check is, I think, yeah, if current is not present, maybe we'll do one thing. We'll do one thing. It's not like I remember any of it, so I'll go on the go. I'll start previous year. Okay. I'll be starting current in the next place, so I'll go with current here. We'll see. We'll figure out how we can do that. So previous is equal to head. That, and current will be equal to head dot next. Current will be equal to head dot next. Now, are both the values equal? Are both the values equal? Yes. Previous dot value is equal to current dot value. Okay. If both of them are equal, current has to move forward, searching for a place where they will not be. So if both of them are equal, you see I'm writing it on the go while visualizing it, okay, while figuring out the solution. This is exactly how you have to do it as well. Previous and current are equal. So I'll move current equal to current dot next. Okay. Now current and previous, again their values are equal, again current equal to current dot next. Okay. Now, current and previous, both values are not equal. What should I do? There is a good chance for me to eliminate these two values. How can I eliminate? How can I eliminate? Can you give me the link, guys? How can I eliminate? How can we modify it? Can you complete this? If previous dot value is not equal to current dot value, what can I do? How can I eliminate it? If previous dot value is not equal to current dot value, what else we can do to modify it? It's not attendance, wrong answer. Okay, attendance is not the wrong answer, is not the correct answer, it's wrong. How can we eliminate? How can we eliminate it? Attendance link is the wrong answer. I'm asking about how to join previous and current. Okay. No, we don't have to. So no, we don't have to do it. We have to relink, guys. We have to relink. You see, previous is pointing to this pen here. Now what we will do is previous dot next will be equal to current. So if both of them are not equal, okay, if both of them are not equal, let me write it here. We will keep else. If both of them are not equal, previous dot next equal to current dot next. Okay, that's it. That's it. Previous dot next equal to current dot next. Now previous and current have point, like previous is pointing to current. Now here you need to again repeat the cycle. Previous should come here, current should move to the next one. Okay, so here after this, previous is equal to current, and comma, I'll just write it. Current equal to current dot next. If you observe, we are doing these two at the same place only. So I'll modify this a little bit. Okay. So I'll go with a simple if previous dot value not equal to current dot value, then previous dot next equal to current dot next, previous equal to current. Then we can remove the else part and we can make it one single thing. So let me erase this. Okay. We can, or if you guys are being confused, let me leave it as it is. When we code it in lead code, then I'll modify it. So here, what did we write? Is the else part. So previous dot next equal to current dot next. Both are equal. Sorry, current equal to current dot next. Current equal to current dot next. Done. Now previous came here, current moved here. Current and previous both are equal? No, not equal. So previous dot next equal to current dot next. So these two will also be linked. Now again, previous will come here, current will move here. Now previous dot value and current dot value both are not equal. So again, what will happen? Both of them will be linked again. So previous dot next equal to current dot next. Now previous equal to current. So previous will come to this place. Let me write it. Now current will move forward. Current equal to current dot next. Sir. Now see, previous, sorry, this is previous. Previous dot value is equal to current dot value, this one. So current will move forward. Previous dot value equal to current dot value. So current will move forward. Previous dot value is not equal to current dot value. So what will happen? See this? Previous dot next equal to current dot next. Sorry. Previous dot next equal to, I think I made this one mistake. Previous dot next equal to current, maybe while removing it. Previous dot next equal to current. Okay. So next, previous will come to this position. Current will move forward. Okay. Previous and current are equal. So current will move forward to search for something which is not equal. Now current became none. So we need to keep on repeating these steps. We need to keep on repeating the steps while current is not equal to none. And if you observe, we left out this part. Okay, this is not like we'll have 50 and 50. So if we make previous point to none, everything will be fine. Okay, let's do that. So let's code it out. So I hope you will watch this question again on YouTube and try and solve it just like me on a piece of paper. You will understand everything I'm trying to do. Okay, now let's coming back here. Let's try to do it. I don't remember the solution, so we will again go back to the board that where we have written it, and we will copy all the code from there. Okay. First, dummy equal to list node. I'll create a dummy node. Okay. Dummy equal to list node. I'll create a dummy node. Dummy node doesn't need to have any values. Okay. Next, after creating it, dummy node dot next equal to head. Dummy node dot next equal to head. Or maybe if we make this as dark mode, things would be better for us. I could see it here itself. Okay. Done. Now let's type it out entirely. Now, previous is equal to head, current is equal to head dot next. Okay. While current not equal to none, while I still have nodes with me, if previous dot value is equal to current dot value, both the values are equal, current equal to current dot next. Current will search for a location where they are not equal, search for a node where they are not equal. When they are not equal, previous dot next will be pointing to current. Previous will take the place of current. Current will move forward. Current equal to current dot next. You see here, these two, we can reduce it to a single. I'll reduce that once we submit it. Now, once we do all of this, once we come back, if there is any duplicates at the ending, I'll not be able to link that. Okay. I can actually link that to the current. So you see, we can go with previous dot next is equal to either current or none. Okay. Because both are same only. So I'll directly write it as why confuse you. So once everything is done, I just need to return the head. Who is the head? You see, we are using dummy here. So return dummy dot next. It is pointing to the head. I have not actually used a dummy node here, but when you are repeatedly going to perform operations in the next question, that is remove duplicates from linked list, sorted list to, here you will be using dummy node. So I have written it here itself. So figure it out yourself. You will understand the usage of dummy node. When should we use dummy node? Repeatedly, whenever you want to change the head, you have to use dummy node. So now let's see this. Let's see if this one works or not. We might get an error for when the linked list is empty. You see how many nodes they will give? They will give 0. So we will definitely get an error for that one. So let me show you by just running this. We will be able to satisfy the sample test cases, but hidden test case will fail. Where the linked list is having 0 nodes, linked list is empty, or where we only have 1. Because I'll be accessing head dot next. If head is none, None.next will be error only. So this is where we will be having error. So let me submit it. It will fail for the hidden test cases. It will fail for the hidden test cases. You can see second test case only failed out of 168. Why? Why? Because head is empty. So this is the hidden test case. This is what we call edge case. They are pointing out here as well. So to bypass this hidden test case, if head is empty means head is equal to none, then I don't even have to return any remove anything. So return head only, happily return it. Or if you have only one node means header dot next is equal to none. If head is none means linked list is empty. If header dot next is none means you only have one node, then you don't even have to remove anything. So return head happily. Okay. So I can have this, there is this runtime error. I can have it as my test case. I will add one more test case where I'll just keep a single value in it. Then run it. This should satisfy all the edge cases as well. And when we submit it, we will be able to pass through. We will be able to go through all of those test cases. Now you see, 100% and space is also optimized. This is the correct solution, perfect solution. Okay. Understood? Understood this one. Take a screenshot of this if you want. Take a screenshot of this one. Okay. You see, now let's optimize it. You see, we will reduce the number of lines. So what I'll do is I'll cut out this part. If they are not equal, then I'll do this previous. If they are equal or not, this is what's going to happen. Okay. Yeah, see, I made it a bit shorter, and even we don't need this actually, if you ask me. I'll remove this part as well, and I'll happily return the head and happily return the head. Okay, everything is fine. This is the proper solution. Dummy node, you can use it in the next one. I have given you the details to solve it. Now run it, submit it. I hopefully no issues. Submit it. This is the better code, and the code that I have written earlier will help you with the next question. Will help you with the next question. Writing it in less number of lines. Now, is there anything else left to optimize? I don't think so. We will not be able to optimize anything. That's it. That's the best, right? So, what's your homework? What do you need to complete? What do you need to complete? You need to complete the next question, that is remove duplicates from sorted list to. Here you will be using dummy node. I have given you the hint of dummy node as well. Question number 82. Question number 82. Okay. Question number 82. That's your assignment for today. Done. That's it. That's it for today. I think we are good to go. I've discussed a lot of questions today. With this, it marks the end of linked list, and it marks the end of the 10th day. Next week, we will be going through stack, we will be going through queue, we will be going through tree, we will be going through graph, I think. I have to check the syllabus again. And at the ending, we will have a good idea about dynamic programming also. Okay, that will give you a good start, right? Done. So, any doubts, any queries you have, any doubts you have? We still have 8 more minutes. Any doubts you have till now? Till now, anything that you want me to explain again? Any doubts you have till? Any doubts you have? Any doubts you have? Enjoyed today's session? So array and strings are data structures. That's one thing that you can get started with. After that, it would be linker list only. Okay, the order is linker list, stack, queue, tree, graph. Okay, these are the data structures. In tree, you will have binary search tree. You will be having AVL trees. Okay, and then you can go with try hash table as well. That's one thing. Hash table is anyway technique. We have seen it. But collisions, you can study the other 3D part. So linker list. The answer for your question, if you have gone through arrays and strings properly, linker list. Otherwise, start with arrays and strings, then linker list. No, you don't even have to arrange the list. Okay, this one is remove duplicates from sorted list. Like you're asking for sorted list one, na? I'll give you the same answer here. You don't have to rearrange anything. You see, I'll go with test cases. You gave me 1 comma 2 comma 2 comma 3 comma. You see, 1 4 they will not give you. Okay, I understood your question. You wanted me to check if 1 4 will be given. Okay, they will give you a sorted list. You see, they said it is a sorted list. You don't have to check. The list is guaranteed to be sorted in ascending order. So you don't have to sort it. They will sort it. It's guaranteed to be sorted. If you give it in this manner, na, as a test case, they will throw an error. Let me show that to you. Linker list, like lead code internally also checks all the test cases and all. You see, list must be non-decreasing. Means you have to give a sorted list. So that's an error. They will give you a sorted list. You don't have to worry about it. Okay. Perfect. Clarified. Now then, so enjoy your weekend and do watch the lectures again in YouTube. Okay. I'll see you on Monday. We'll be closing 5 minutes early today. So see you on Monday. Bye bye. Have a good weekend.